Hello, this is section 2.3, question number 5. The directions say, evaluate the limit and justify each step by indicating the appropriate limit law. Now I know this can be tedious to do, but when we're learning, it is important that we specify which limit law we're going to use, so that way we don't make mistakes as we get into harder problems. Okay, so number 5 says we're supposed to figure out what the limit as t approaches -2, t to the fourth minus 2, all divided by 2t squared minus 3t plus 2. Okay, so we're going to evaluate this limit. Now once again, it can be very tedious to write out each limit law and what the step is. So after we've practiced that for a few times, I'm not actually going to do that in practice anymore. But for this particular problem, it's asking us to do that, so let's actually do that. Okay? So the first limit law that I'm going to use is limit law number 5. And that says if I take the limit as x approaches a of a rational function f of x divided by g of x, I can rewrite this as the limit as x approaches a of f of x, all divided by the limit as x approaches a of g of x, as long as the condition that the limit as x approaches a of g of x is not equal to 0. So that's limit law number 5. So then what I'm going to do is rewrite this limit using limit law number 5, placing the limit as t approaches -2 on both top and bottom of the rational function. So let me do that. The limit as t approaches -2 of t to the fourth minus 2, all divided by the limit as t approaches -2 of 2t squared minus 3t plus 2. Okay? So I did that by applying limit law number 5. The next limit law is, we're actually combined two of them, but number 1 and number 2, it says that if I have the limit as x approaches a of f plus or minus g, that's the same thing as the limit as x approaches a of f plus or minus the limit as x approaches a of g. Okay? So I can take a limit, I can split them up across addition. I'm going to apply this limit law number 1 and 2 together on my original. So for the top, I have the limit as t approaches -2 of t to the fourth minus the limit as t approaches -2 of 2. Okay? And then for the bottom, I'm going to have the limit as t approaches -2 of 2t squared minus the limit as t approaches -2 of 3t. And then one more, plus the limit as t approaches -2 of 2. Okay, let me erase this side over here. Okay, so the next limit law that I'm going to use is number 3. And number 3 says that if I have the limit as x approaches a of a constant times a function of x, then I can rewrite that by saying that this is equal to the constant times the limit as x approaches a of the function of x. So in other words, what I've done is taken the constant and moved it to the outside. I took the constant and moved it to the outside. So now it's out front. Okay? So I'm going to do that with some of the terms. I'm going to do it here, and I'm going to do it with this term. So let me rewrite that. The limit as t approaches -2 of t to the fourth minus the limit as t approaches -2 of 2. Then I'm going to apply limit law number 3. So 2 times the limit as t approaches -2 times t squared minus 3 times the limit as t approaches -2 of t plus the limit as t approaches -2 of 2. Okay? So I applied limit law number 3 to my original function, and I moved the 2 to the outside and moved the 3 to the outside. All right. The next limit law that I'm going to use is limit law number 6. So let me erase this side of the board. Okay, so limit law number 6. That says that if I have the limit as x approaches a of f of x raised to the n, that's the same as the limit as x approaches a of f of x, all of it raised to the n. And that's the situation that we have for this limit and for this limit. This is f of t raised to the fourth. This is f of t raised to the squared. So I'm going to take the actual function and put it on the inside and square the whole thing and raise the whole thing to the fourth. So this whole thing is equal to the limit as t approaches -2 of t all raised to the fourth minus the limit as t approaches -2 of 2 all divided by 2 times the limit as t approaches -2 of t and then squared minus 3 times the limit as t approaches -2 of t plus the limit as t approaches -2 of 2. Okay, so we're almost done. I only have 2 more limit laws to write. So let me erase over here. Okay, so limit law number 7. Limit law number 7 says the limit as x approaches a of some sort of constant, that is equal to the constant itself. And we're going to apply limit law number 7 to this limit and to this limit. Then we also have the situation for number 8 limit law. That says that the limit as x approaches a of x, well, that's just equal to a. So we're going to use limit law number 8 for this place and this place and that place. Okay, so here we go. The limit as t approaches -2 of t. Well, using limit law number 8, that's just equal to -2. But that's still all being raised to the 4th. Minus the limit as t approaches -2 of 2, that's limit law number 7, so that's just equal to 2. Then 2 times the limit as t approaches -2 of t, again, that's limit law number 8, then we have to square it. So 2 times -2 and then squared. And then -3 times the limit as t approaches -2 of t, limit law number 8, so -2. And then finally, plus from limit law number 7, that's just 2. All right, so I've run out of room here, so let me continue down here. This would be 16 minus 2, so that's 14. And then this is 2 times 4 plus 6 plus 2, so that's going to be 16. And that simplifies to 7 over 8. Okay, if you have any questions, please send me an email or feel free to stop by my office hours.